Paul, if I'm looking to build a house, obviously these days there's a lot of materials available, let's say specifically for the walls. What should I choose to build my house with if I'm looking to build something that's pretty energy efficient?
What we build out of, what architecture is made out of, historically is about what materials were available back in antiquity, So if you were in a forest, there was timber available, you built things out of timber. If there was clay available and not much timber, you tended to build things out of clay bricks or out of adobe or rammed earth or things like that. So that's kind of architecture, when it gets down to it, is all about available materials, and it's a climate response, right? In Perth, you probably noticed, we built out a lot of brick, a lot of double brick. Clay was available, limestone was available, but limestone wasn't a great material. The reason we built out a double brick mainly is just very, very good marketing by brick manufacturers 100 years ago, right? In the eastern states, they built out a lot more of timber. A lot more houses are built out of timber, okay? There's other materials, natural stone like limestone, or over the last 30, 40 years, there's been a resurgence in Western Australia, particularly in rammed earth. Probably started in the southwest, and it's become a typology of wall material in the southwest. Right, it's a historically built a lot in other parts of the world, because it's simply taking the local dirt when you haven't got any other material and ramming it into forms and creating a wall. Adobe construction in North Africa, in North America, was used a lot. The technology was developed a lot better here in Western Australia, and it's appropriate. It's become quite common, but a very good material for building walls out of, right? So pros and cons of different materials. So if you're building with a solid material like brick or rammed earth, they're solid, they've got a lot of thermal mass, meaning they'll hold heat, right? So the sun gets on them, it warms it up, and it stays warm for the evening or the night. If you're building out of what I call lightweight construction, like timber framed walls, the heat passes through quite quickly, so it cools down quicker at night. The hot heat doesn't hold it, but in winter it doesn't hold that heat, which you probably want as a thermal mass, right? One of the best materials to build out of is what we call reverse brick veneer. So you have a brick inner leaf, a brick inner wall, and then a gap, and then a timber frame outside and some sort of cladding. We call that reverse brick veneer. So you get that thermal mass inside where it's mass and that can heat up and then stay warm, but you've got that cladding on the outside. I'm a very, very big fan of rammed earth. I just think it looks great. It's generally, environmentally, it's a very, very low carbon footprint, because it's not usually materials taken from close by. It's made on site. It's actually made on site. You don't have to transport bricks or other materials. It's got a great thermal mass. It's thick. The walls are thick, so they've got a wonderful cave-like quality. There's no other finish to it. That's the final finish. And I just think it looks good. I love the material.
So you mentioned reverse brick veneer as a really good choice for your walls. Can you tell me a bit more about that?
So again, reverse brick veneer is a thicker wall. It has a brick, what I call a leaf of brickwork is the wall of brickwork, and then there's a gap, and then there's another wall that is usually timber framing, and then some sort of cladding on the outside. What is good about it, the great advantage of it, is that the brickwork on the inside has a thermal, massive thermal quality. So that means that it will absorb heat and then re-release it later, right? As opposed to, say, timber framing, which doesn't have any thermal mass. So the temperature will move in and out through that wall quite quickly. Whereas a reverse brick, it doesn't. Then you can have a different cladding on the outside. In Perth, we use a lot of it's very common to use double brick, a brick cavity wall, which is two leaves of brickwork with a cavity in between. Okay, so that was developed the reverse brick, the double brick was developed. The cavity is basically to protect from rain. If you had to, back in the days when you built castles in England, they were solid brick, and the water could eventually migrate through, and it relied on the fact that inside was warmer and the water would evaporate before it got there. So the cavity in that double brick is basically to mitigate water coming through. So the outside leaf, the outside wall can get wet, but the cavity keeps the inner leaf dry. That's how they work. Now, in Perth, it's probably the most economical way to build. It's just how we do it here. Everybody's familiar with it. And it is the most inexpensive way to build. But most houses, even less expensive houses, are built out of cavity brickwork.
And can you make those double brick, those classic walls that we have here in WA, can you make them any more energy efficient?
You can. So the best way to make them more energy efficient is to insulate the wall. You know what an R value. People know what an R value is. It's you talk about insulation with an R value. In the higher that R value gets, R4, R5, R6, the better the wall is insulated. So if you insulate that cavity, and traditionally walls in Perth were not insulated, it makes a huge difference. So a brick cavity wall hasn't got a great R value, but the minute you put some insulation in the wall, quite simple, it increases that R value by a lot, and then gives it a good insulation value.
Let's say we've got a few different wall options here that we've talked about. So there's just your timber framed wall, which I think you mentioned is more common over east.
Yes.
But it's an option here. Then we've got the double brick. Then we can have the reverse brick veneer, which is where we only have the brick on the inside and then some sort of cladding on the outside, or rammed earth, let's say the fourth option.
Yes.
How do they compare with cost?
So probably overall, not a lot of difference in the cost. The rammed earth is a bit labour intensive on site, but the finish you get is the final finish. So if you're building out of brick or timber framing, generally it's plastered. The brick is plastered. It's either rendered on the outside or it's left as a face brick. Just as the brick. Inside is always plastered and then painted, and the same with the timber framing. It'll be some sort of cladding both sides. So with rammed earth, that's it. That is the final finish. With brickwork, you then got to add plaster finish, a paint finish, and a cladding to the reverse brick veneer. But overall, they're probably similar costs. There are other factors in a building, obviously, but that we're just talking about the external walls at the moment. And
so, if you were building your own house, Paul, say right now, which wall type would you choose, or would there be a mix of wall types?
That's a good question. It depends on the site. If you've got a tiny site in a city, then maybe something like brickwork or reverse brick might be the answer. If you've got a big site, a holiday home, which is a bit more casual, I'd definitely do it out of rammed earth. There are some projects. There's a model in front of us. It's an early model, but the lower level is in rammed earth, and the upper level then has a band of reverse brick veneer. So we end up having a mix of materials. So it just breaks up that wall. Rammed earth on the bottom, the timber on the top. So this particular house was meant to be fairly raw. So we've got roof gardens on top, which were native gardens, and then we've got that band of timber which is going to left to go grey, and then the bottom of our level is in rammed earth. It's in a coastal suburb, so using limestone in the rammed earth seemed appropriate. It was like an indigenous material from the site.
And Paul, can I ask one last question? Is there any type of wall that perhaps you've seen underperform in terms of energy efficiency?
Yeah, good question. Again, it's very climate specific. If you're building in a temperate climate like Perth, I think you want some thermal mass and insulation in the wall. If you're building, in a tropical climate, then perhaps you don't need that thermal mass. Probably you don't want that thermal mass. I still think that you'd want it insulated. Mm-hmm. So if you're building in, say, Norway, right, lots of timber. A lot of those buildings are made timber frame, but they're heavily insulated, and they have a little fire inside. That insulation it keeps, insulates the inside, and that even a little fire will heat up, right? Heat up the house. But if you had no insulation, it'd be a disaster. You'd have a lot of issues with condensation for starters, and the cold would just come straight through. So again, the selection of materials, particularly for walls, is very climate specific.